In Chapter 1, Lesson 2, Part 1, we will be discussing the product of powers rule. This is something that we will be using to simplify exponential notation. The product of power rule is used to, again, help us simplify. The rule states that when you're finding the product of two algebraic expressions with the same base, you can add the exponents. So when you see something with the same base, again, it could be a number, it could be a variable, it could be a fraction, with being multiplied with the same base, we can simply add the exponents. So this a to the third power times a, which again, remember, when something is written without an exponent, a 1 is implied, can be simplified to a to the power of 3 plus 1. And as you know, 3 plus 1 equals 4. So a to the third power times a simplifies to a to the fourth power. The variable can represent any number at this point. Let's practice simplifying some expressions using the product of power rule. Here we have 5 to the 8th power times just 5. Again, remember, when an exponent isn't listed, a 1 is implied always. So 5 to the 8th times 5, we're going, because it's the same base of 5, we can just add the exponents here. We add 8 and 1. Since 8 plus 1 is 9, that problem simplifies to 5 to the 9th power. And this can be used with any type of number. So here we have negative 2 to the third power times negative 2 to the 7th power. We keep our negative 2 in parentheses, and we add our exponents, 3 plus 7. As you know, 3 plus 7 equals 10. So it simplifies to negative 2 to the 10th power. They simplified it even more to positive 2 to the 10th power, because as you know, if you multiply two negatives, it will equal a positive. So since our exponent is an even number, because our exponent is a 10, we can actually just change that negative 2 to a positive 2. If it was negative 2 to the 11th power, we couldn't simplify it that way. We would just leave it as negative 2 to the 11th, because this is an odd number. And again, we could do this with any kind of number, even fractions. So 2/3 to the 5th power times 2/3 to the 3rd power. We're simply adding those exponents again and raising it to the 8th power. Your job is simply to simplify. I am not asking you to evaluate any problems in this section. Let's do some practice on our own here. In number 1, in lesson 1.2, we have 13 to the 4th power times 13 to the 9th. Again, because our base is the same, I'm going to use the product of powers property. In that property, it tells me I can keep my base of 13 and add my two exponents, 4 plus 9. So all I'm going to do to simplify is do the addition of those exponents. So I keep my base of 13, and 4 plus 9 is 13. So we have 13 to the 13th power. We're going to do some more practice here. We moved on to number 8, just to show you how different kinds of bases can be used with the same product of power rule. So here we have a variable of b, which it doesn't have an exponent, so a 1 is implied, times b to the 6th power. So again, I'm using the product of powers property. I'm writing a little bit bigger than the line, but you get it. So b times b to the 6th power, I'm just going to do b raised to 1 plus the 6th power and simplify as b to the 7th. I can do the same thing with my negative q's here. Negative q to the 3rd power times negative q to the 3rd power. I will always be using the product of powers property when I see two bases multiply times each other. So I'm going to keep it as negative q to the 3 plus 3. And then that becomes negative q to the 6th power. I can again simplify this one more step because this exponent is even. I can actually just turn my base into a positive q because I know that multiplying a negative times a negative becomes a positive. So it simplifies to q to the 6th power. Now number 10 here, I have a base with both a coefficient and a variable. A coefficient is that number in front of the variable. Coefficient, just write that in there so you're familiar with the term. So 4s to the 8th power times 4s squared. Because they're the same bases, again, I'm using that product of powers property. I'm going to do 4s and add my exponents up here, 8 plus 2, and simplify it by actually doing the adding. I'm keeping my 4s in parentheses because I'm saying that I'm raising everything inside to the 10th power, not just the 4 or not just the s. On this page, I want to show you some examples where we have multiple bases being multiplied times each other. Just because we can actually simplify this a little more than you might think. Here we have a squared b cubed times a cubed b squared. Remember, anytime we have two variables next to each other, even if there's exponents in between, it simply means they're being multiplied. So to help us simplify this even more, we're going to just spread this problem out. We're going to break it up by variables. So here I have a squared times b cubed times a cubed times b squared. Because I know the commutative property says that in multiplication, the order doesn't matter, I'm going to switch my parts of the equation around so that my bases that are the same are next to one another. So here I have the a squared and the a cubed. And then I group my b cubed and my b squared. So again, I'm just putting them next to each other so it's easier for me to see the bases together. So using that product of power rule, now I know that I can combine my bases of the a by adding the exponents of 2 and 3. Same thing, I can combine my base of the b by adding the exponents 3 and 2 from the b's together. So because 2 plus 3 is 5, I have a to the 5th power. And again, 3 plus 2 is 5 times b to the 5th power. If you wrote it as a to the 5th power times b to the 5th power, there'd be absolutely nothing wrong with that as well. We just don't need that multiplication symbol there, only because they're variables, so we know they're separate. The next problem here in B, we have a little different situation because we have coefficients with two different variables. Because my coefficients are not inside of parentheses, there's no parentheses, I'm actually going to separate them out. So again, a coefficient next to a variable simply means multiplication. So this 4p right here, I'm just going to split up into 4 times p squared times q to the 4th power. And then here, I'm breaking apart the 2 from up here and separating it times p to the 4th times q to the 6th. So like I did in the problem above, now I'm going to group like terms. The 4 and the 2 here are like terms because they're both just numbers. And then I have my set of p's and my set of q's. So first I'm going to actually multiply my 4 and my 2 to get 8. And then I'm going to use the product of power rule to simplify my variables by adding my exponents. So p to the 2 plus the 4th turns into p to the 6th, and q to the 4th plus the 6th power equals q to the 10th, and then we keep that coefficient right in front of our terms. So let's try some together here. Here we have x squared times y times x to the 4th times y cubed. So again, I am going to separate the product out here by breaking those terms apart. So x squared is going to be its own term times y, x to the 4th power times y to the 3rd. I want to regroup the factors with the same base. So now I'm going to put my x's together. X squared, x to the 4th, y. And if you need a reminder, again, if no exponent is present, just put a 1 there, times y to the 3rd. Now I'm going to add the exponents of the factors with the same base to simplify. So x times 2 to the 4th. X to the power of 2 plus 4 times y to the power of 1 plus 3. And then you simplify by doing the actual adding. 2 plus 4 is x to the 6th. And keep my base y. And 1 plus 3 is 4. And let's do some more here without the step-by-step given to us. C to the 4th, c to the squared, times c to the 5th, c to the 6th power. First thing I'm going to do is break down the product. C to the 4th times d squared times c to the 5th times d to the 6th. I'm going to regroup. C to the 4th times c to the 5th times d to the 2nd times d to the 6th. Going to simplify here by changing this now to c to the 4th plus the 5th times d squared plus the 6th. And then I am just going to add those together, and I get c to the 9th power, d to the 8th power. All right, let's do one that's a little more complicated. I'm going to start up a little higher just so I have enough room. I'm going to write this out, separate out every term, including those coefficients. 2 times j to the 3rd times k to the 5th times 3 times j squared times k to the 7th. So now I'm going to group everything with its like terms. So 2 times 3 times j to the 3rd times j to the 2nd times k to the 5th times k to the 7th. So now I'm going to start doing the math where I can. 2 times 3 is 6. I'm going to jump ahead here and start simplifying together so that you can see j to the 3rd times j to the 2nd using the using the product of power rule is j to the 5th, because 3 plus 2 is 5. And then k to the 5th times k to the 7th becomes k to the 12th, because 5 plus 7 is 12. So that's it for the lesson on the product of power. Again, if you need more practice, there are some extra problems in your reteach packet.